Looking at 8, which is the scientific notation for a length of 0.0000923 centimeters. Well, that would be, we need to rewrite it. So there, our base number would be, our base number would be 9.23. Now, how many times do we have to move the decimal point from here to get to there? 1, 2, 3, 4, 5. So that would be 9.23, and our base number would need to get smaller, so it would be a negative 5th power. So 8 is B. 9, simplify the expression. Alright, so we got to simplify this. Seven minus 2, we're just going to rewrite it out. 7 minus 2, that's squared, plus 6 minus 2 cubed. So 7 minus 2 gives us 5 squared. Then you're going to add 6 minus 2 is 4 cubed. We need to write it out now. 5 squared is 25, because that's 5 times 5, plus 4 cubed, that's 4 times 4, 16, times 4 is 64. Now we need to add these together. 25 and 64, 5 and 4 is 9, 6 and 2 is 8. So we should get 89. 9 has to be 89. Dollar bill is about that many meters thick. Where's this thickness in scientific notation? So we have 0.00011. We need to write that in scientific notation. Our base number in scientific notation would be 1.1. Every number in scientific notation is multiplied by a power of 10. We need to move it 1, 2, 3, 4 times. But our base would be getting smaller, so that has to be a negative 4. 1.1 times 10 to the negative 4th. 10 is B. 11. Distance of 6.5 times 10 to the 8th is multiplied by 10. The result is written in scientific notation. What is the new exponent? Okay, so we're multiplying it by 10. That's 6.5 times 10 to the negative 8th. We are multiplying this times 10. So let's write this out. 0 point, and we would need 7 zeros. 6, 5. Do we have to do this? No, but we're showing you just how much of a pain actually writing it out is. So this, we're multiplying this by 10. Multiplying by 10 simply moves the decimal once over. So we would get 0.123456 65. Now, what is this in scientific notation? 6.5 times 10 to the 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th. So the exponent would be negative 7. Now, what's happening here is our base is being multiplied by 10, which means our exponent actually just increases by 1. If it's multiplied by 100, our exponent would increase by 2. If it's multiplied by 1,000, our exponent would increase by 3. 3 powers of 10. Moving on to 12. Square garden has an area of 1,600 square feet. How long is each side of the garden? So this square, the area is 1,600. So what times itself gives you 1,600? So number times itself equals 1,600. Well, I'm going to take off these 2 zeros real quick. I see 16. And I know that 4 times 4 gives me 16. I need 2 more zeros. So if we make that a 0, 40 times 40, let's multiply that out. 40 times 40, 0 times 0, 0 times 4, bring down a 0. 4 times 4, 0 is 4, 4 times 4 is 16. So 40 times 40 gives us 1,600. 12 has to be B. 13. Which of these is most likely to describe the number of yards lost in a football game? So, you gain or lose yards. You can write that here. So if you gain yards, if you're on the 10-yard line, you get to the 20, you gained 10 yards. But if you're on the 10-yard line and you go back to the 5, you lost 5 yards. These are the types of numbers that represent yards lost in a football game. That would be this one. This would be yards gained, this would be yards lost, and this is an integer.